Alright, so we're looking at scientific notation, and as it says here, scientific notation is a way of expressing numbers using powers of 10. And we have, for example, here 2.32 times 10 to the 7. So when we're converting numbers to scientific notation, we want to have one number in the unit column followed by decimal places times by 10 to the power of something. Alright, so we've got convert the following quantities to standard scientific notation. Let's look at the examples. So the first example here is 23,200, and what we've done is we've taken the first number and put the decimal places after that. So we've got 2.32 times 10 to the 4. And I like to think of it whenever I'm converting numbers from scientific notation, or from their normal numbers to scientific notation, I like to think of how would I get back from our scientific notation back to the original number. So if we start off with this 2.32, we need to times it by 10,000 to get it back to 23,200, and 10,000 is expressed like this way, times 10 to the 4. If we now look at the second one, we have 3.4 times 10 to the negative 3, and that was originally expressed as 0.0034. So if we look at 3.4, how do we get back to 0.034? Well, we'd have to divide 3.4 by 1,000, and that's expressed as times 10 to the negative 3. So if we've got a number here, a small number 2.32, and it wants to go to a big number originally, or it was expressed as a big number originally, then we need to have a positive indice up here, so times 10 to the 4. And if we have, in this case, we have 3.4, which is a larger number than 0.0034, we had to divide this number to go back to the original, and so that's expressed by times 10 to the power to a negative number here. So if this is the first time you're seeing negative indices, it's like saying divided by that many numbers. So if we look at this example here, so we've got 4,500,000. So the first thing we want to do is write those 4.5, and then work out how many, or times 10 to the power of something. And we need to work out what the indice is. So if you count the amount of numbers after our decimal place, so we put our decimal place after the 4, so if we count the numbers after 4, it's 1, 2, 3, 4, 5, 6. So it's 4.5 times 10 to the 6. And when we look at prefixes, you'll start to know that times 10 to the 6 is equal to a million. So this is like saying 4.5 million. Now, in the second example here, we've got 0.45. So again, we express that as 4.5. But to go from 4.5 back to 0.5, we have to actually divide by 10. And if you notice, this decimal place has moved one spot. So it's like negative 1. So that's another way of thinking about it, is how many spaces has the decimal place moved. And this has moved one spot from there to there, so we'd have to go times 10 to the negative 1. Let's go over here now to 27.8 times 10 to the 3. So we want to express that with the 2.78 and times 10 to the power of. So if we go from 2.78 to 27.8, we have to times that by 10. So in effect, this becomes times 10 to the negative 2. So we've increased our indice by a power by 1 because we had to times it by 10. So it goes from 10 to the negative 3 here to 10 to the negative 2. Okay, we've got 3.4 for this next one. And let's count the amount of decimal places we had to move that. So 1, 2, 3, 4, 5. So this is saying times 10 to the negative 5. Alright, let's keep on going then with this one here. Click out of that table thing, formatting. Okay, so we've got 232 times 10 to the 7, so we want to express that as 2.32. And if we just focus on the first one, we've got times 10 to the 2. So that handles our going from 232 to scientific notation, but we've also got times 10 to the 7. Now, hopefully you're familiar with the indice laws. When we have when we're timesing powers together, they add, so it becomes times 10 to the power of 9. And there. This one here, again, it'll be 2.32 times 10 to the power of 2. So that handles our 232 times 10 to the negative 7. Okay, so again, adding the indices, we have 2 plus and minus 7. So that becomes 2.32. Oops, 2.32 times 10 to the negative 5. Let's keep going with these ones over here now. So we've got 4,500 times 10 to the 5. So 4,500 is 4.5 times 10 to the 3. Then times 10 to the power of 5. That's 4.5 times 10 to the 8. This one here, we've got 5.6 times by 10 to the power of 1, 2, 3, 4, 5, 6. So minus 6. Okay, now let's just do this one in one step. So we've got 1, 2, 3, 4. So it's going to be 5.6 times 10 to the negative 4. And then if we add and minus 6, it's going to be times 10 to the negative 10 on there. So this one here was 5.6 times 10 to the negative 4. And then we subtract a further 6 off that to get to the 10, negative 10. This one here becomes 5.6788 times 10 to the 2. So then overall it's going to be 5.678 times 10 to the negative 6. Alright, so hopefully that was clear for you, and I'll see you next time.